You have a question. Very good afternoon. I welcome all the registered students, practicing engineers, my faculty colleagues to this live session of this course Thermal Engineering Basic and Applied. I request you all who are attending this session, and if you have any questions, queries, to raise your question so that we can start our discussion now. I also request you all to post your question in the chat box so that we can start this session. I request all the registered students, faculty colleagues, and practicing engineer who have joined this course in MOOCs platform and also attending the session to post your question in the chat box so that we can start our discussion now. This course, Thermal Engineering Basic and Applied, is an important core course for the students, I should say the graduate students, and also the undergraduate students specializing in mechanical engineering, electrical engineering, power engineering, chemical engineering, and there are several modules of this particular course, starting from the basic part of the thermodynamics, which is essentially needed to understand the remaining modules of this course. In this particular course, we have discussed basic part of thermodynamics. Then we have discussed about the steam power module, steam power cycle. And in this particular module, we have discussed about the basic power cycles, then their modifications, essentially to get more output. And then we have also discussed about the boiler and flow nozzles, steam turbines, and condensers. In this particular course, there is another module wherein we have discussed about the internal combustion engines. And in addition to these two important modules, we have also discussed about the gas turbine units, basic refrigeration cycle, which is also, an important part of this course. We have discussed that the cycle which is used to describe all the processes in a refrigeration or refrigerating plant constitute a cycle, and this is known as power cycle, but the sole purpose is not to produce power, but to produce refrigerating effect. We have discussed this particular cycle, and also we have tried to understand several processes. Those are there in a vapor compression refrigeration cycle. We have also discussed about the nomenclature aspect of the refrigerant. Refrigerants are a special type of working fluid which are used in a vapor compression refrigeration cycle. Then we have also talked about the gas turbine units, both open and closed cycle units. We have talked about the cycle efficiency. Then we have also discussed about the effect of intercooling, which is again an important aspect of the gas turbine units. In this particular module, we have also discussed about combined cycle concept, wherein we had seen that a significant part of the energy is used to run the bottoming cycle wherein we are getting power output. Had not we used that energy from the topping cycle, that is the gas power cycle, the efficiency of the unit would have reduced significantly. So I request all the students, practicing engineers, and my faculty colleagues, those who have registered with this course and attending this session, if you have any queries or comments, kindly raise your comment. Else you also can post your comment in the chat box so that we can start our discussion now. We have solved a few numerical problems for each module of this course, essentially to illustrate the conceptual part of this course. And since there are several modules, as I had mentioned, steam powered cycle, gas powered cycle, refrigeration cycle, and then internal combustion engine. Essentially, for this particular module, that is for the internal combustion engine part, we also had to introduce a few year standard cycles like Otto cycle, diesel cycle, etc. For the steam power cycle, the working fluid is water and water vapor mixture, while for the remaining cycles, those are discussed in this course. The working fluid or working fluids are either air or a special type of working fluid, that is the refrigerant. So we have discussed several aspects for each component, considering their operational as well as design perspectives. I request students, learners of this particular course. Also, I had seen there are faculty colleagues from different institutes, and they have registered with this course. Request you all to post your question in the chat box. I must mention here that even you will be having questions later on, please feel free to post your question either in the tutorial platform, or you also can email me. I shall be happy to get you back with the solution or answer of those queries. I request you all, those who are attending this session, or already if you have any questions, kindly raise your question now so that we can start discussion on those questions. This course, Thermal Engineering Basic and Applied, as I had mentioned, is an important core course wherein understanding of basic thermodynamics, heat transfer, and to some extent fluid mechanics is essential for an understanding of the operation as well as design of several components. Considering the requirement, or I should say significant, or understanding of basic thermodynamics, which is an important part of this course, we have tried to discuss the basic thermodynamics part, at least the components of thermodynamics which are important to understand several processes in the applied part of this thermodynamics. So, having a thorough discussion on those topics, those are important to understand the operational as well as design aspects of several applied thermodynamic units. We have discussed first law applied to the system as well as flow and non-flow processes. Then we have also discussed about that when we are discussing about cycles, certainly we have also discussed that to analyze the cycle, what are the important points to be considered before someone starts analyzing any particular cycle, be it a vapor refrigeration cycle, be it a gas power cycle. Then we have also talked about an important module of the steam power plant, that is the boiler. So we have discussed about the flow processes or different cycles. Those are present inside the boiler to make the system complete. So if we try to recall that in a boiler, we need to supply energy in the form of heat. Upon receiving heat from the external source, water gets converted into vapor. Whether we need saturated vapor or superheated vapor, boilers should be. So we have discussed all these aspects considering both water tube and fire tube boilers. Thereafter, we had discussed about flow nozzles. The steam which is produced in the boiler is taken to another device, that is the turbine, but it is not a case that steam as it is produced in a boiler will be taken directly into the turbine. Before steam enters into the turbine, steam is allowed to flow through a nozzle, essentially to get a steam jet. So the design aspect as well as the flow analysis for the nozzle is also important. We have also discussed that particular component in this course as well. Then we have discussed about steam turbines. We have solved a few numerical problems on this particular component. We had also discussed about the steam turbine classifications. Then we have identified the mechanism by which rather when steam is allowed to flow through the turbine, in the course of steam flow through the turbine, we get work output. So the mechanism of energy transfer from the flowing steam to the shaft, this particular mechanism we have discussed considering both impulse and reaction turbines. Then we have also discussed about another important module of the steam power plant, that is the condenser. Because we know that second law of thermodynamics puts a restriction that no, heat engine, no device can run in a cyclic manner while exchanging heat with a single temperature thermal reservoir. So illustrating that particular concept, we have discussed the need of having a condenser in a steam power plant. Then we had seen that condenser is essentially a type of heat exchanger. We have discussed the working principle of a condenser. Then finally, we have discussed about the cooling tower, because the coolant which is used to reduce the temperature of the steam that comes out from the turbine is the water, and upon receiving heat from the exhaust stream from the turbine, the coolant's temperature increases in the condenser. So we have also discussed that hot coolant that comes out from the condenser is not permitted to discharge directly into the ponds, nearby lakes, or any reservoir because of several environmental constraints. So we need to reuse that coolant. And in this particular context, we have also discussed the need of a cooling tower. We have also tried to solve a numerical problem from the cooling tower. So essentially, in this particular course, we have tried to discuss several applied thermodynamical units, wherein understanding of basic thermodynamics and heat transfer is, or these two subjects, understanding of basic thermodynamics and heat transfer, is important or necessary. Then we have also discussed about the internal combustion engine. We have briefly touched upon the combustion processes. Then in the context of internal combustion engine, if you try to recall, essentially we are having energy transfer. So we need to supply fuel to the engine cylinder. We need to supply fuel into the engine cylinder, and the fuel which is supplied to the engine cylinder is having some energy in the form of chemical energy. That energy is again converted into the mechanical energy which is available at the shaft of the engine. So to get this energy conversion, or to have this energy conversion, there are several processes, and those processes are those processes occur in a cylinder, and that is also known as the cylinder of the internal combustion engine. So we have discussed this particular module as well. Then finally we have discussed about the fuel characteristic, and afterwards we have discussed about the vapor compression refrigeration system. We had seen that if we need to map the processes, those are there, or the processes, those constitute together to form the vapor compression refrigeration cycle in different thermodynamic planes. From there we have estimated the efficiency, because since the efficiency is not the proper term to be used to measure the performance of a refrigerating unit, so we have discussed about coefficient of performance. Then we have defined an important unit, that is tons of refrigeration. What does it mean? We have also discussed. Then finally, we have discussed about the gas turbine units and several important aspects, modifications needed to increase the efficiency of the gas turbine units. For each module, we have solved a few numerical problems, essentially to illustrate the concept of the theoretical part of that particular module. I request the students, learners, my faculty colleagues who are attending this session, if you have any questions, to post your question in the chat box so that we can start our discussion now. If you already have a few queries or questions, please feel free to raise your questions now. You also can post your question in the chat box so that we can discuss them now. As I mentioned, you also can post your question later on in the tutorial platform, or you also can directly email me the questions. I shall be happy to give you answer of those questions in the return email. So I request all the students, learners, and practicing engineers who are those who have registered with this course and attending this session, please post your question in the chat box. You are also requested to post your question later on in the tutorial session. Also, you can directly email me the questions and I shall be happy to give you answer of those questions in the return email. I can understand that there are no questions from the registered students, practicing engineers, and faculties of this particular course. So I request you all, even now, to post your question in the chat box so that we can start our discussion now. I can understand that you do not have any questions, you do not have any queries to be discussed in this session. So I should repeat once again that even if you do not have any question now, and you might have several queries later on, please feel free to post your question in the tutorial session. You are also requested to email me the questions so that I can write you back with the solution of these questions in the return email. I hope you do not have any questions for this session today. So I would like to wrap up this session for the day. And I once again request you all to post your question later on, either in the tutorial session, or please feel free to email me the question so that I can reply you back with the solution of these questions. So with this, I stop this session today. Thank you very much.